Hello everyone, my name is Davide Calandra and I am a junior assistant professor at the Politecnico di Torino. I will present the paper titled A Testbed for Studying Cybersickness and its Mitigation in Immersive Virtual Reality, recently published on the IEEE transaction on visualization and computer graphics. Cybersickness is a well-known issue in immersive virtual reality, affecting 20 to 80% of users exposed to this technology, making it a key barrier to VR usability and adoption. Over the years, various mitigation techniques have been explored, including field of view reduction, dynamic or static, blur effects, optical flow manipulation, and external hardware solution. However, there is no standardized way to evaluate these techniques systematically at the moment. So, current cybersickness research faces three main challenges that are the lack of standardized evaluation methods, the high variability in test scenarios and measurements, and also the need for effective and broadly applicable mitigation strategies. To address this, we introduced the CitVR, a standardized testbed to systematically compare cybersickness mitigation techniques. The testbed is open source, extendable, and it follows the same philosophy of LetVR, a previously published testbed for locomotion research. Why focus on full immersive VR? Because cybersickness is most severe in this context compared to semi-immersive or desktop-based virtual reality. To address this, CitVR includes 4 standardized scenarios covering key cybersickness factors, a taxonomy-based approach that was used to select those scenarios, ensuring relevance and scientific rigor, and a mix of subjective and objective measurements, including, for example, the simulator sickness questionnaire, some performance measures done by the testbed itself, and also the physiological measures like the heart rate variability. Then it's integrated with existing cybersickness mitigation strategies, such as the Ginger VR repository, which is a collection of previously published techniques, VR Tunneling Pro, which is advanced implementation of the dynamic FOV technique, plus additional implementations, again coming from the state of the art. One key contribution of this work is the taxonomy of the cybersickness evaluation scenarios. Most studies use custom scenarios, making cross-study difficult, and also they usually tailor the scenario to the specific technique implementation. So we started by categorizing the scenarios based on different aspects. First is the locomotion style, that could be either body-centric, so walking virtually or in the real world, versus vehicle-centric, so using real or fictional vehicles. Then the body-centric locomotion can be either split in terms of degrees of freedom. There are mostly rotational scenarios that are trade-off, categorized as trade-off, like the follow target scenarios where you are standing still here to rotate yourself, and the stationary shooter. So they could be also furtherly categorized based on the increase of the pace or difficulty of carrying out the task and the scenario itself. Then there is the 6DOF with gravity category, which is essentially the full range of movements on foot. And they could be, we start from the free exploration, adding layers of complexity, so follow path, navigational search, up to the full shooter type. Regarding the vehicle-centric locomotion, they could be categorized furtherly based on the level of control. So controlled motion, where the user have the full control of the vehicle, could be usually driving simulators or racing games, depending on the type of the simulation, or uncontrolled motion, where you have autonomous driving or passive driving, up to the roller coaster, which is one of the most common and also extreme kind of scenarios. So by structuring the scenarios this way, we ensured a broad coverage of common VR experience where cybersickness is a concern, and selected 4 representative scenarios, one for each subgroup. The first scenario of type trade-off rotational it's a stationary shooter declined in form of tower defense. So it induces intense rotational movements to the users, both on the horizontal plane and the vertical one. the user has to defend a tower constantly rotating to aim and shoot to approaching enemies. And this scenario tests how rotational movements can impact cybersickness and can evaluate mitigation techniques oriented for this kind of stimuli. The second scenario, the navigational search, represents a 6-DOF body-centric experience where the users explore both indoor and outdoor area to collect items. And unlike shooter-based scenarios, the navigational search, which is the most common of this subcategory, allows for a wider accessibility and helps examine how cybersickness affects free navigation and its impact on standard locomotion techniques. The track race is then the vehicle-centric control and motion scenario simulating high-speed racing experience, featuring sharp turns, straight section, and uphill and downhill sections. It tests motion-induced cybersickness in controller vehicular environments and integrates wall-hitting mechanic for the task inspired by prior research on cybersickness mitigation. Finally, the roller coaster represents the uncontrolled motion scenario where users experience abrupt accelerations and drops. Designed to stimulate extreme motion variations, includes interactive elements to keep the focus of the user on the task, and tests intensity-based motion sickness triggers, evaluating techniques for fast uncontrolled motion. To validate our testbed, we conducted two studies. A pilot study to refine the scenarios and metrics, followed by a use case experiment evaluating a particular technique, which is the masked dynamic FOV, an advanced variant of the popular dynamic FOV, available in the VR Tunneling Pro asset, that consists in letting the developers to tag important elements of the scene to exclude them from the application of the technique, so reducing the impact on the actual gameplay. The main experiment involved 34 participants and it followed a between subjects approach, subdividing the users. Half of the participants experienced the mitigation technique and half no mitigations. Regarding the subjective measures of this experiment, for what it concerns the simulator sickness questionnaire, we can see that MDF, so the masked dynamic FOV, significantly reduced the cybersickness symptoms in the 4 scenarios, all the symptoms in 3 out of 4 scenarios, and only 3 of them class of symptoms for the navigational search one. And vehicle-based scenarios show the strongest improvements due to the intense motion stimuli. Whereas the navigation scenario, which is usually the one used to evaluate these kind of techniques, showed the smaller improvements, which is probably the reason why some previous research failed to find a significant difference with respect to the baseline condition. And no major impact was found on the presence measured using the presence section of the VR use questionnaire, showing that MDF is effective without impacting immersion in presence. Looking at the objective results, we can see that always in favor of the technique is the improvement in terms of operation speed in the navigation search and roller coaster scenarios, showing that the techniques allow users to sustain higher velocities and also higher accuracy in the track race, so allowing the user to better focus on the task. There is also a way reduced withdrawals in terms of in case of extreme cybersickness in the navigational scenario, showing that the technique allows longer, prolonged periods inside the virtual environment. And this is the relevant results. To summarize, CTVR provides a standardized testbed with 4 diverse scenarios and multiple mitigation techniques, combines subjective and objective metrics, and allows reproducible cybersickness evaluation. Among the limitations, it covers only 4 scenarios, so needs broader coverage, no natural walking support, and is primarily focused on visual mitigation techniques. The next steps will involve expanding the scenarios, adding, for example, indoor-only and aerial settings, integrate natural and redirected locomotion, and investigation of long-term effects of habituation, so the VR legs concept. Finally, there will be also an investigation of cybersickness effects on patients with multiple sclerosis in collaboration with the University of Cagliari. If you have further questions, feel free to reach out to email or let's discuss at the conference. Thank you for your attention and goodbye.